Our life. What is this, Lady Ada?
Hey everybody, and welcome to Show and Tell. It's our weekly Show and Tell. We do this every week at 7:30 p.m. Eastern Time. It's me, Lady Ada. With me is Mr. Lady Ada on camera control.
Hello.
We also have Scott and Dan who are visiting, and we'll be viewing your wonderful projects and maker things and costumes and whatever else you're working on. So take the next couple of minutes. We're going to go through everyone who's shown up, and we got to get out of here at 7:50. So please mute your mics while everybody else is presenting, and then when we call on you, take 2 minutes to demo your project. Let's start off with JP.
Hello. I got my mute button.
Hello.
Nice work.
Welcome back.
Thanks. So hey, I just got back from vacation and went right to work doing a live stream of the second half of my iPad pinball game controller. So I wanted to show that. This is the controller with the iPad in it. My iPad is quite new compared to when this thing came out, so I've put a couple little pieces of wood temporarily to allow it to fit in here without falling out. That's not really all that necessary when it's sitting on the table, but I didn't want it falling off while I was showing it here. So what this is this is a controller. Here's the second one that I've taken apart. You can see the guts. It had a little Bluetooth keyboard or a little Bluetooth controller in it, essentially. And it spoke to one particular pinball app that's not the one I really wanted to play. It's not a great one. I'm not even sure if it's available anymore. But these are like $9 on Amazon now. So I got it and removed the guts, and I put in it instead a little teensy. And so this teensy is acting as a HID keyboard. And the game I want to play, which is called the Pinball Arcade, uses the iCade standard, if you can call it that. And iCade, what it does is it has keyboard keys mapped to pushing this button down and then up is like H and R, and pulling the plunger down and then releasing it is X and Z, and so on. So I mapped all of those keys to these buttons, wired them up, and I'm using the little USB to lightning connector that Apple makes. They call it their camera kit, I think, meant to transfer photos. But some devices can be plugged into it and powered successfully. They have to be pretty low power like this teensy. And then I also connected a onboard LED that was in the controller to the teensy as well, so that I could see that it's plugged in and powered on. And if you take a look now, when I pull my plunger, I get the virtual plunger to go. And now I've got, I'm going to try to play this without, now I've got the real button working, which is awesome. This is a really hard game, actually. It's a really old-fashioned one. So one of the things with the Pinball Arcade is it's all licensed tables, incredible reproductions of licensed tables. The people who make it, I'm forgetting their name now, the studio that makes this game has bought all these tables. They take them all apart. They 3D model every single bit that matters of it, and they have really good physics simulation of every piece, every type of material, the rubber that was used in a particular bumper and all that. So it all feels really, really good. It's really true to life. It's kind of impressive because it's one of those things that you really just want to play a real arcade game when you, or a pinball game when you want to play one, but they cost a couple $1,000 easily for these tables. So I'm now real happy that I've got Pinball Arcade running on this, and I'm gonna put up a little guide on doing this exact build that kind of follows along with the 2 streaming videos I did, as well as just a generalized guide to using the teensy as a arcade controller with buttons, kind of like a 3-button project, as Lamore put it earlier. So that's my little pinball controller.
Okay.
Hey.
Does it do, JP, does it do tilt?
So
No.
the game does tilt. I think I have to have a ball in play. And so you can touch the top of the screen here and it'll do tilt.
Oh, nice.
I really tilted it, right? Unfortunately, it doesn't recognize the accelerometer of the iPad when you're telling it to use a real controller, which in the settings I'm saying use an iCade controller. Those are mapped to buttons, so I have a few options there. I messed around yesterday a little bit with using one of our little vibration sensors and a tilt switch, and those both work because I'm able to connect them up to some pins on the teensy. So that's a possibility, or just a couple of extra buttons if you didn't really want to physically tap and move the thing. But yeah, that's a really good question, Scott. I think it'd be a fun upgrade to allow tilt. It actually tilts in 4 directions, I think. No, 5. It does 2 side tilts, 2 diagonal tilts, and 1 straight up tilt. So it's really thorough as far. I don't play pinball that much, and especially don't play with like a really mean tilt game. But maybe this will help me develop that.
Okay. Next up, Tony D. Tony D, what you got this week?
Hey, yeah. So if you like Bluetooth Low Energy and MicroPython, check out the YouTube channel, because last week I did a stream on using this guy, the NRF52 Feather, and how to get an early port of MicroPython compiled and running on it. So someone made a port of MicroPython to this the chip that powers this, the NRF52, and it works pretty well. It's definitely not for a beginner. You need to compile the firmware. It's still early days for the port. It's based on an older version of MicroPython, and a lot of the settings and things might need to be tweaked, but it does run. You can get a REPL. There's a basic Bluetooth API, so you can control the peripheral and the central modes on this chip. So I think we'll see a lot more in the future from this, but it's still pretty cool and exciting that it's another platform that MicroPython will work on for it. So definitely check that out.
Yay.
Okay, awesome. And we'll have a sped up version of your video and last week's video as well on Ask an Engineer.
Sweet.
Cool.
Next up, we got a full house tonight, so we're going to keep moving to Noah and Pedro.
Hey guys, hi
Hey, guys.
everybody. So last week we released the super simple LED eye project. So you can like just stick these anywhere, no microcontroller, just a small little 12mm breakout board, 3 printed little clip on there. That was last week. This week we have, so was it 2 weeks ago? We put together like a little replica of this guardian robot from the Zelda new video game, Breath of the Wild. You can show it. And so just a couple upgrades to it. We added a servo and an LED in the eye, and it's running off of a little Trinket microcontroller, and inside is a little LiPo battery and like a little LED strand that was kind of like fashioned around it. But the print was designed by Steve Imbleton, and he uploaded his design on Thingiverse. So I figured I'd give it a shot. So my contribution to the project was like just creating the circuit and designing a little custom bottom so that it would house all the electronics. It wouldn't be floating around in there. So it's kind of fun. Put up a nice little guide for that as well. Yes, there's a guide up. So if anybody's interested in making like a cosplay prop that just kind of randomly rotates and has like blinking lights, definitely check out the project. And
For Halloween stuff, because you can print anything.
yeah, totally. Yeah. Or your event con thing. Yeah. Okay. And huge shout out to Phil B, who helped me out on the software to make it rando-y, because I had it pre-programmed. It was just like brings his life. Yeah, very fun.
We will be showing some of those videos on the show tonight.
Sweet. Thank you.
Okay, we're going to go to John, who I think has his daughter, and then we'll go to Chris Young, if Chris, you want to get ready. John
Hey,
Swoop,
John.
I think you have an engineer there.
Okay.
Yeah, what's your name?
Claire.
Hey, Claire.
Claire.
What you got?
So, my dad has his light up sousaphone. I have a light up ukulele.
Oh, awesome.
Bling, 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 bling.
We started making this. Right now, it's just neopixel strip, just all the way around. We glued it on with some hot glue, just temporarily. It's doing a test pattern. We just have everything hooked up to my circuit playground. It's there. And we just have stuff hooked up with alligator clips right now because we haven't soldered it all yet. But this is my light up ukulele. Yeah.
Yay. All right, so email support@adafruit.com, and we'll send you an As Seen on the Show and Tell sticker, which can go anywhere on that transparent ukulele.
Okay.
All right,
Awesome.
good work,
Thanks,
Claire. All right, next up, Chris Young. Welcome back, Chris. What you got going on this week? Yep, you sound great.
Okay. Well, you know, mouse control has always been a bit of a challenge for me. I can do it with my dictation software. I also have an infrared mouse that I can go up, down, left to right, or diagonal. But if I want to do anything quickly or more proportionally, it's a little bit difficult to do. So we're going to do a quick screen share. Oh, hell. Hang on. Close window.
There's us. Hi, yes.
Yeah, hang on.
My posture is terrible.
Yeah, all right. Starting to go.
Let me just slouch over my laptop.
Yeah. It's starting to look like a skunk or something. I don't know what's going on.
Go to sleep. Okay, anyway, if you do a Google search for a joystick mouse, you'll come up with this device called the Joust 3, or joystick mouse. And as you can see in the little photograph there, it comes with a nice stand. You move the joystick with your mouth, and it controls your computer. And if you look down here at the bottom of the screen, you can have one for $1,495 plus $55 shipping and handling.
Get two.
Absolutely insane. I can't imagine that someone unknowing would Google this, stumble across it, and actually pay that amount of money. So I'm going to outdo them, of course. This is a photo of me driving by using a joystick that I drive my wheelchair with. And so why don't I replace that with a different joystick for mouse control. Got an Adafruit analog XY joystick. Build a 3D printed mount for it. I took the big rubber knob off. It didn't work very well for me, and put a little 3D printed stem on it.
Yeah.
This drops into the same collar that I used to drive with, and that's what I've been using during this entire show and tell to maneuver the mouse. And so, it took me a day to throw this thing together. It works really well. I can play the timed levels of Candy Crush now very fast.
Important stuff.
Yeah. But there's another option out there that I want to highlight. This is a project from a makers group in Canada called Lip Sync. And this is a completely open source joystick mouse. It has an Arduino micro in it. They built their own joystick because the analog joysticks, like the one I've been using, most of the people that tried them said it was a little bit tough to use. So they've actually designed their own joystick using force resistors. And I'm also using a push button in my hand to click, but this has a tube on the end of it that you can blow into to click the mouse or select on the tube to right click. As you can see here, they come with complete parts lists, links to where you can buy all of the parts. Some of them are 3D printed. They provide all the STL files that you need. Extensive instructions, step by step, how to assemble it. It's a really quality open source project. And I'll probably end up building one eventually myself. But I just wanted to show off my sort of quick and dirty version. And then highlight this great open source project. I don't know what the lip sync costs, but for an Arduino Micro and a handful of parts, you can guess what it costs. It certainly isn't $1,495.
No. For that, you can make a few thousand of them, maybe, or at least a few hundred. Bill in the chat said he's assembling one this week. He wanted me to tell you.
Yeah, I knew he was working on one. And
all right. Well, thank you so much, Chris, as always. Once again, happy birthday. Thanks for sharing your birthday last week. And
all right. Thanks for sharing.
Great project.
It was a lot of fun.
Yeah, and whatever sticker you want, of course.
Yeah, of course.
All right, next up, Morgan. Hey, Morgan, welcome back.
Hey, can you hear me?
Yep.
Yeah. Hello? Okay, awesome. So lately, I've been doing a lot of outreach with Girl Scouts and schools and everything, but I've realized that the projects that I'm doing don't really represent my real work. I'm a mechanical engineer, and I work in industry, so I make huge, giant machines that take 100 feet of space. So last week, I was at a science teachers convention and realized there's 100 little mini-me cart bots that run around, but there's nothing that really represents industry really well. So I started a project where I'm working on a giant open source demo conveyor kit. I'm going to flip the camera over, hopefully to the top view. This thing is about 6 foot by 4 foot by 2 foot right now. So this is just the conveyor portion. So it's pretty small, or it's not done yet, but I'll flip it on. It just moves things right now.
My first factory.
Basically, yeah. So yeah, it just moves stuff.
Cool.
But the cool design aspects are it's mounted on pegboard. And so that means that you can, all these parts are 3D printed or just drilled through holes on 1x2s or 2x2s or other standard wood pieces. So you can move around and reconfigure your conveyor however you want. Also, I'm accumulating all sorts of other things I want to add in, like I've got an IR distance or an IR sensor.
That's cool.
A stack light, because everyone loves stack lights.
Yep.
And the idea is eventually I'll have, and it's guarded too. You can't really see here, but I'm building functional guarding into everything. So by the time I'm done, it'll have 2 circuits. There'll be the one that's, you can swap out your own programming and try out different things on the conveyor line. And then the other one will be the safety line where if you open the doors, if you hit the e-stop, all that will function as it should. Because while I love letting kids try whatever they want, sticking your hand in a conveyor belt also isn't a ton of fun. This conveyor belt wouldn't hurt you though. It's made out of craft foam and PVC pipes, and the motor is pretty low torque, so you can jam your hand in there and the belt will slip before it actually pulls your hand in too. An ongoing project, if you have any good ideas for sensors or features or cool things that you could do if you had a tiny factory in your yard, let me know. I'm thinking of doing like a color sorter into boxes,
That's cool.
maybe doing like a vision system overhead, all sorts of things I can do. So yeah, let me know if you have any ideas.
Okay, outstanding. If you send some photos to, I think you have my email address, or you can email support. We can post it up, or we can give you a guest blog account. This would be cool. We are what we celebrate. If kids see that they can build this stuff, we can get more mechanical engineers.
Mm-hmm.
Yeah, we need automation engineers. We can't hire enough for them. So if automation in factories is your thing, there are going to be tons of jobs there.
All right, and of course we'll send you out a sticker as well. Okay, we're going to keep going. We're going to see around. Mark, unmute your mic and show us your project. How's it going, Mark?
All right, can you hear me?
Yeah.
Hey.
All right, let me present the right window. There we go. All right, so that should display, yes?
Yay.
Mm-hmm. All right, so yes, LEDs. Probably the best thing to show is a very quick video. So initially, I had one of your 8x8 matrices, which had all kinds of color as long as they were green, red, or orange, because they were using a max chip that didn't do PWM, so you couldn't mix the colors yourself. So I got those bare matrices, which basically have no chip, and you just drive them directly, and then spend time writing a driver to actually have a matrix that's compatible with your library, and then display anything you want using the Adafruit GFX library. On the left here, you're seeing how the PWM works by slowing it down a lot. It gives you an idea of how it redraws. And then when you go at full speed, then you end up with different colors like that. So that's how it started and how I wrote a few demos. Of course, 8x8 is fun, but we can do a lot bigger now. And of course, now you have neopixels, which make the whole thing much easier. You don't have to do all the crazy scanning that I'm doing. And Adafruit matrix library makes it a lot easier. So that's a 7x7. That's a 8x16. So that's the same demo code running on all of them, which, by the way, you merged recently, so thank you for doing that. And let's just make it a bit bigger. Okay, that's still the same one. This is a 12x12. Here it's showing a 24x24 bitmap that's being actually scrolled to the size of the display that it's in. And this one you might recognize, even though it's dark. That's one of your panels where you're also doing the crazy row scanning to actually refresh on each line. So this is the panel anyone can buy that you have a library for. So I made the same demo code work on that, which you have also merged, so thank you for that, including multicolor bitmaps. And so that you recognize as actually your code right there. And then can we do bigger? And the answer is yes. That's a 24x24. That took an insane amount of time to solder. And basically still, again, running the same code. This one definitely cost more time. It's still one big row, just everything in line. But I have connectors on the side, so I can actually make it 8 times 24. And with a fast LED library, I can run 8 lines at the same time to get a higher refresh rate. But the matrix library doesn't support that yet. And honestly, it's been fast enough that I haven't really spent the time to do that. But basically, yeah, same code running on many different platforms, all the way down to basically pixels that you do by hand, and then yours, and then of course neopixels, which make life so much easier.
All right.
Okay.
Outstanding, Mark. Email support@adafruit.com. Any of the panels get an as seen on the show and tell sticker. We're going to get to the last two folks. If you can keep it to a couple minutes each, we can get out in time. So we'll go to Scott, and then right afterwards, Philip. So, I'm sorry, Adam, and then Philip.
You show your stuff on the show.
Yeah.
Yeah,
Okay.
I'm not worried about it.
Yeah.
Hello, Adam. Oh, you froze. Oh, hey.
Oh, me now?
Yeah.
Okay, cool. So I realized that throughout this whole thing, I hadn't really covered how the electron microscope works. So I'm going to try to do that in 3 minutes, and we'll see how this goes.
Okay.
So the first thing with this thing is that you have to get electrons to input. And to do that, you need to call an electron gun. And on my particular microscope, this is my spare electron gun right here. What you do is you flow current through a tungsten filament. The tungsten filament heats up, and when it heats up, it starts throwing electrons off. And you take a really high voltage potential, and you extract those electrons from that filament and start shooting them down the column. And so we've got, using that high voltage potential, we're basically sucking electrons down my column through the one-off, which is the plate that is at ground, and through my scan coils. And my scan coils are a bunch of different quadrupole magnetic coils that effectively can condense and expand the beam to make it a single beam of electrons. And then there's coils at the bottom that are varied in magnetic field strength, and that turns the electron beam, kind of bends it around and scans it through my chamber. And at the same time I'm scanning my beam through my chamber, I'm also scanning the beam on my CRT monitors. So if the beam is on the upper left-hand corner of my chamber, it's on the upper left-hand corner of my CRT monitor as well. And it's important, you'll see why in a second. Because when an electron beam hits a sample, what happens is that it gives off secondary electrons. So those secondary electrons are given off in different quantities by different elements, different textures. And there's a lot of things on the sample that can affect how many secondary electrons are given off. So if we scan the beam and we count how many secondary electrons are given off in one part of the beam, or one part of the sample right here, we can display that number as a brightness on the CRT monitor. And if we keep on scanning each individual point and keep on counting how many electrons are coming off each individual point, we can build up an image slowly. And the reason this works better than an optical microscope is because an optical microscope requires that you keep in mind the wavelength or how wide light is. With electrons, that wavelength is really, really tiny, so you can see much finer details. And that's what enables this electron microscope to work, is basically just using that really tiny beam of electrons and scanning across the surface and counting how many electrons come back off of wherever you're hitting it with the beam. So that's the really quick rundown on how this microscope works. And there's all sorts of more crazy details, like how do you get high vacuum, how do you move a sample around, how do you capture the image. But beyond that, that's the fundamental theory of operation of this thing, and any microscope you find will work in the exact same way.
All right, you did it. Outstanding. Well, whatever sticker you want, of course. I mean, we'll see you next week and keep working on this awesome project.
I have the stickers are like electron microscopable. Eventually.
All right, so Phil Moore, keep it to a couple minutes, and then we're going to wrap up with Dan showing his, if we got time. All right, how's it going, Phil?
It's going okay. I have one of John Park's robots. Yay. Only instead of using the Arduino 101 on it, I put the Metro M0 Express, and it's running CircuitPython.
Good choice.
And so right now what I'm trying to do is get it to drive the motor shield correctly. And it has IR sensors on it for hazard avoidance. We have polished concrete floors here at work, and so it's ideal for running around in the hallways.
Perfect.
So
great.
It can avoid people and walls at this point. It can't do edge detection or stall detection.
Yeah.
So if it runs up on carpet, it'll stall, and it will happily fall downstairs. So I need to figure out how to do edge detection.
This is part of the automation project that maybe Morgan will eventually do. So we had a DHL robot called FEBot here at Adafruit, and it followed Lady Ada around, put packages in, and all this automation and robot following and avoidance, like it's all converging on the same things that I think this is really good. All right, well, your robot or you get a sticker, email support@adafruit.com.
All right.
Okay.
Thank you. All right, and last up, Dan, show us the thing you got.
So this is,
hold it up?
Yeah, I'm gonna move it closer to you. This is a
is
project. This is a thing called the Digital Logic Microlab, which I built when I was in junior high school. It's from 1970, and made by Southwest Technical Products Corporation, which did a lot of the popular electronics kits at that time. And so this is sort of the circuit playground of its day. It's got 4 flip-flops here. It's got 4 NOR gates. It's got a bunch of RC circuits, so you can build clock circuitry.
Can you show the back too?
Yeah, it's got a lovely circuit board.
Oh wow!
It's got it uses RTL logic and
I
got
thought
transistor
the chips
drivers.
are shiny, like the chip used to be shiny. Like
It's a gorgeous, and it's a
gold pads.
It's a really nice piece of fiberglass circuit board, and
whoever
did it.
Motorola flip flops.
Yeah, I love how fluid it is too. It's
whoever did this,
no straight lines on the
right. Whoever did
this
was obviously done by hand. This is way before CAD programs. So, and if it has some debounce, I can make it click. You can see that it's counting up here as I'm doing this here.
It's genuine, not to hide.
Yes, and there's a wood case inside here.
I like how 120 volts is just exposed. It's like, hey.
Oh yeah, there's some
Come on, man,
there's some wire nuts here. Yeah, but I haven't told myself yet.
All the people that would
that'll learn
tell
you.
me about that.
Yeah,
when I was holding it.
That'll learn you.
I like these are neon bulbs too.
No, these are not. These are just filament light bulbs.
Oh.
Yeah.
And they got the transistor driving each one.
And those are still working? Wow.
Yeah, so this is from 47 years ago, and I had it in my drawer, and I took it away from my parents' house recently, and it still worked. So I'm really happy about it.
Yeah.
Well, thank you, everyone. That was show and tell. Claire, if you can unmute your mic and play us out if you get a chance. Thank you, Phil. Thank you, Pedro. Thank you, Morgan. Thank you, Mark. Thank you, Claire. Thank you, John. Thank you, Chris. Thank you, Adam. We'll be here every single week. Here we go.
Good.
I want to show now.
I was gonna say, I hope we don't get content.
This is great. I totally didn't know that you was gonna. I thought I was just going, yay! Good work, Claire. All right.
That's some sweet ukulele.
Wow.
You could totally be in the background of a commercial for Blue Apron or something.
Yeah. every iPhone app is like bling 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 bling. So you want to order cat food?
Keep practicing. Come back next week.
All right. Thank you, everybody. We'll see you on Ask an Engineer in just a few minutes. Bye bye.
I wish I'd played ukulele.
I know.